Okay, it's going.
All right. So before the break, we were talking about the Nmap services file and how inside of that file there was the default listing of the services. Based on nothing more than we got back a reply during the probe, maybe it was a TCP or a UDP packet we sent, and we got back some kind of a response. We may have gotten a reset to an ACK, or we got a send ACK to a send, something that indicates that the port was open, and then we automatically get the suggestion from Nmap that this is probably the most likely service that's running on that port. Then we can also go ahead and do a, that was again these files are in user share Nmap if you're using the Kali build that we recommended for the class. There's also a service profile that we can use to do the service version scanning. We've done a couple of service version scans and compared those against what the suggested value based on just the port number itself was. If you look inside this Nmap service probes file, what you'll see is blocks that start with next probe, and anything that starts with the hashtag is a comment. So you can grep for these or search for these blocks that say next probe to find the next sections, and then you'll find the probe declaration followed by the probe itself. So this one is just simply a null. It really is the most basic of all probes, and then it has a little description. And it waits for about 6 seconds to see if there's going to be any information given out by the service. And the service may or may not respond. And if it does respond to this particular probe, the null probe in this case, then there's a series of matches that are applied to see if the response back from the service matches one of these patterns. So in this case, the probe appears to be looking for F5C61A. The /X indicates it's hex. And if it matches on that, then it would say that that's one of these 1C Enterprise Business Management servers. There's going to be, in most cases, lots of matches for any given probe, because one probe could elicit responses from any number of different services running on any number of different operating systems. And you can see the name of the match is in the first column as well. I didn't mention that before. So of course you can search these files looking for different servers that you might be interested in. So there's the Microsoft ActiveSync. It's probably one that people know about in here. Somewhere in here is, in this first null section actually, is the MySQL matches. So MySQL will respond to a null probe. So, in some cases it's matching on text. So like here it's looking for a standard response, a 220 semantic antivirus scan engine ready. And if it matches that, it'll say, oh, that's the semantic antivirus scan engine, oddly enough, right? And it associates that with semantic. So there's actually quite a few services. I was surprised when I was looking through here to get ready for this talk. I was amazed how many services will reply to the null or the empty packet, if you will. So there's about as many of them in this section as there is for just about anything. So let's see if we can find MySQL. Let's see, what's catted in there. And we get a whole bunch of matches. And these are for different kinds of MySQL server or different responses from slightly different versions of the MySQL server. Or it could even be programs based on MySQL server. So it's kind of interesting. Some of them are in different languages and so forth, so it can detect the same server that maybe have the language set to something other than English. So any questions on how the service probes are defined or how the matches are sent out? We can take a look at some of the other probes as well. Remember, the probe starts with the probe declaration. So you can find the probe by grabbing on the word probe, capital P. So here's the first one we looked at. It was the TCP null probe. And here's some more. So this probe here is doing the carriage return line feed and carriage return line feed. There's a GET request. Adrian had mentioned this one earlier in his talk. There's a GET, slash HTTP slash 10. This would be the old version of HTTP that still runs actually on some embedded operating system devices like networking equipment and so forth. And then here's the HTTP 11 and several others. So it's kind of interesting to look through there, and you'll see a similar pattern throughout the entire file. There's going to be a probe and then a series of matches, and then it'll go on to the next probe. All right, so we'll bring our version back up again. And we did earlier we had done an Nmap on 192.168.56.101, and we hit port 3306. That was the MySQL. See if that machine is still listening.
It doesn't matter where that P goes, right? It could go after the IP address and it's still going to be fine.
Yes. I believe to a large extent you can pretty much put the options anywhere you want.
Yeah, Nmap's very good about being in a place just about anywhere. There's surely some exceptions for that.
Yeah.
But generally, yeah, you can put it in any place.
Matter of fact, you can even do stuff like put the P next, or the number next to the P option, and it doesn't really seem to phase it. You can, define port ranges. I think I have some examples over here we may even be able to find. Yep. So here's some examples. These are all totally legitimate designations. So I don't want to try these lower ones because they scan all the ports. But let me see if I can make this a little bit bigger.
Except for one of those, well, some of them don't scan 0, which may or may not be available. And
yeah, jumped down a little bit too fast.
Actually, does the -P-65535, does that scan 0 or not? I wonder.
Does it hit 0 or not?
Yeah.
That's a good question. I don't know.
We can sniff it later.
Yeah. So if we did, okay. So there's the -P option, and then you can do ranges. So if we want to scan ports 1 through 2 or 1 through 3, maybe a better example, we could do it that way. Let's move this to the top. Well, if you want to scan starting at the beginning, you don't really even have to put a number. So you can just say blank -3, and that would get from start to 3. And then if you didn't want to specify an end, you could just not specify the last number either. So that would be all ports. Or you could say, I want to go from 65,000 to the end, and just leave the end blank, like that as well. So yeah, the options are very, very forgiving. And then to test Adrian's theory, I'm going to do a -2, you think? See if,
yeah, I wonder if
see what that does. Okay. That's the fun thing about Nmap is it's kind of, in a way, with TCP dump, it's kind of easy to see what it's doing, so you can just run tests. So let's see, we've got.
It looks like it starts with 1.
Here's us. Yeah, 101.1, 101.2. So, and then 1 and 2 actually did respond back to us with reset acts, so they're closed. So yeah, it does not include the 0. Maybe we can force it to include 0.
Yeah, you can. But you have to actually put 0 there.
Right. Yeah.
And if you
So I guess technically the blank doesn't really mean start true beginning.
true
It means
beginning
start
though,
at
zero is not
1.
supposed to be used. There's a the whole
Start
programming
exactly at
technique
1.
thing she was referring to.
It was listed on the all the listings of all the ports showing that it's supposed to be this. So apparently it has something to do with the busload distribution.
Oh, did you use reason? That also sometimes shows you what flags and why it says something is closed or open.
Okay. Oh, yeah, without having to go look at TCP now?
Yeah. So it's information I think it's not always as accurate, because I think it's sometimes we put a reset, even when it's a reset ACK, but I'm not maybe wrong on that.
Well, when I forced the 0, it did send the send flag to the 0, looking, of course, for a send ACK back, or looking for a reset ACK. We got a reset ACK back. Again, a lot of machines won't send back these reset ACKs. This Metasploitable is just a very polite machine. It's even when the port's closed, it responds with a reset ACK. So, all right, does that answer your questions on that one? Any other questions about the syntax and what we're doing? Just ask if you think of anything so that we don't, jump too far ahead. Especially when you get the margin section later, the difficulty of information is going to spike up a bit. So definitely want to get all the basics down before then.
Just because we can't get to that 56.
Mm-hmm.
I can.
Well, you can, but you're not going to get the same results.
Oh, I see. You're right.
Yeah, you definitely won't get to.
I think at 10.002 I have a Metasploitable box. I'm not.
That's what I was wondering.
10.003.
Oh, someone already found it. Yeah, 10.003.
So
It's really easy to notice. You can own it if you really want to. Just leave it up and running. I won't delete that VM later on anyway. But yeah, 10.003 I have one at.
So then your commands will work a little better on that, and you'll get some results, hopefully.
Yeah.
Let's see. We did 10.003. Hosting's down.
Huh.
I found one that was called Pawn, and it was 114. And it seemed to have, does anybody own 114? Is that one that you have?
On the
00114. Yeah.
Yeah, I can get to 10.003 right now.
Yeah, I can too.
Are you on the network?
Hmm.
Yeah.
And are you netted or non-netted? And
I'm not netted.
students, you
It's like
should
I'm
be.
connected, so yeah.
Yeah, it should connect, and I'm connecting to it, and she's connecting to it, so I'm not sure what's up with that.
It looks like 114 is an IIS server. Is that one that you planted out there?
Oh yeah, probably.
Okay.
Well, I did a quick sweep and see if I can find any hosts that are accessible. That's actually the reason why I use the host-only networks and demos, is because I know that I can always reach them even if the network might be down.
But it's tough for, when I was trying to follow along, I wasn't getting the same results. So
So it looks like 138 is reachable by right now. So
Which network is your host OS on?
host Windows 7
No, I'm saying which network, student or?
student, yeah, it's on student.
Yeah, I'm not. Oh.
Oh, oops. I meant to change that to 138. Well, it's working hard, so I think maybe we're going to get some results.
Oh, should figure out why it was
No, I didn't really figure it out. I just switched to using a different host.
Okay.
So I figured maybe.
Yeah, I'm not so sure. I think every phone attack it's true something on there about routing. Or I'm gonna modify some stuff to see if I can up the number of connections that are allowed. We might be hitting the max limit of what DDWRT does.
Yeah, I think so. Everybody's competing for those, right? All right. Well, I jumped ahead just a little bit to talk about the the different options. Yeah, let me see if I can do that. Let's see if we did. Ah, yes, thanks. All right, no problem. Okay, there we go. Okay, so this is the default location of the services file if you want to look at the one on your machine there and pull up the top 1,000 ports. And then that was ordered by service name, the port number, and the port frequency. Adrian talked about this fast mode earlier. If you run the if you run it in fast mode, you're going to get the top 100 out of that same file. So if we did the exploitable and compared the two together, so let's do the regular mode.
Oh, and I totally forgot about to say anything about that command, indiff. There's actually a diff, so you can compare an old Nmap scan to a new Nmap scan and see what new devices have came onto your network or what dropped off your network.
Oh, okay. That's pretty cool.
It's built in, and or just InCat, and there's a bunch of in tools that they basically built in. InCat is basically their version of Netcat. So
Yeah.
when it's been continued to develop and maintained.
Encrypt or something like that.
No, well, it's Netcat,
It's Netcat.
but it's their version of it, InCat.
All right, so we ended up getting 23 services. I just subtracted the 1,000 from the 977 closed. So we got 23 services in the regular mode. So if we switch to the fast mode, which is only going to search for the top 100 ports, we'll compare those two and see if there's any difference between fast mode and regular mode. Or top 1,000 and top 100 would be the better way to put it. Okay. So you can see that the number of services found in the fast mode is quite a bit less, or at least significantly less, than what was found in the regular mode. Of course, Metasploitable has got an obscene number of ports actually running. I can tell you where the fast mode can come in handy. Sometimes when you're trying to do the host discovery step, this first step that Adrian showed us, just to figure out what the hosts are so that you can populate those into your IP addresses file to go on to the scanning that we're doing now. What you're going to find is that all the ICMP and all that type of traffic is blocked. And in fact, generally most all traffic would be blocked. The fast mode can be used to discover hosts just using the top 100 ports when the ICMP is blocked. And it's going to obviously miss some very odd devices, but the chances are if something is running on a network, it's probably going to have one of the top 100 ports open. You certainly are going to miss some services running on that box that wouldn't be in the top 100, but if you're just doing host detection, the point is you only need to get lucky enough to hit one of those top 100 to know that the host is alive. So, all right, it looks like we got 18 services back with the fast mode compared to the 23 that we'd gotten back earlier with the regular mode, top 1,000. But in either case, we know the host is up. Okay, so we got the dash F. And you can specify with this dash top ports option the number of ports that you want to try. So going back and doing the same experiment, we might be able to say, well, let's instead of fast mode, let's try maybe just half the ports. So 18 with fast and 23 with the 1,000 mode. Let's see what the 500 gets us. Obviously, it's going to take a little bit longer than fast mode, which I think ran in about 13 seconds. This one took 13 seconds as well, so. Actually, we got 21 out of 23 just doing the top 500. So there seems to be sort of a Pareto effect here where the top 20% of your probes is going to get the 80% of the open ports kind of a estimation. And then you can also do port ratio. Now the difference here is instead of saying I want to scan 500 ports like we did in the last example, this one is the percentage of ports that you want to scan. So, and it's not percentage like it's not 500 out of 1,000. It's the ones that have that ratio in the file that we looked at in the third column that have that ratio bigger than the number that you specify. So if you say, I want to only see the stuff that's more popular than 0.1, you know, you could put 10 in there for 10%. And then we actually covered how to specify the port ranges just a minute ago using the range with the dash. You can also use commas as well to skip over. So if we said we wanted to do, let's not do the top ports, but we'll say we wanted to see port 21 through 23, but then we want to skip 24 and just hit 25. We can use the comma to skip part of a range, and then you can always go back later, add more commas, and add more ranges back in. So maybe you wanted to see 80 through 83. And combine the ranges and the commas together to get the list of ports that you want. So that would be about 8 ports. So turns out there's a whole lot of stuff open in those ranges, at least on Metasploitable anyway.
All right, folks, feel free to play with the network, but you might have to occasionally reattach.
Okay. So it's almost like you need to go around the room and tell everybody one at a time so that each person takes a turn connecting. Now, you can try to combine together the protocols as well. This syntax is a little bit rough at first, but basically the U is for UDP. So if you say U colon and then a port range using the ranges or the commas, however you want to do it, and then eventually do the T colon for TCP, you can combine together the UDP and the TCP port ranges into one block. So we can try that. Oops. If you want to do both the TCP and the UDP scans at the same time, I kind of skipped over this. I probably should have mentioned it. If you don't put the SU, then by default, remember that you're going to do the send scan, the SS scan. Unless, of course, you're logged in as a regular user, in which case you're going to do the ST scan, the connect scan. You're not going to do the SU scan by default. So when you specify those port ranges like that, like where we're combining TCP and UDP together, if you just say nmap-p, you know, UDP this range, TCP that range, and then there's also SCTP, I think S colon specifies those. Then look at the difference. In the first one, we got back results on UDP 53, 111, and 137. But when we forgot to say -SU, we missed those, even though we had specified them in the port range. So it's not automatic. It's not automatically going to look at your port ranges and then go back and fill in the scan types so that they all make sense. You have to specify the scan types first and then specify the port ranges. I don't mean first as in the order that you list them, but you have to think through that first. So and then another mistake that sometimes is made is people will say, okay, well, I've got some UDP stuff mixed into with this TCP port ranges, so I don't want to forget to do this. But when you specify only the -SU, you're telling Nmap you want to do a UDP scan. And I'm pretty sure in this case you'll miss the TCP portion of those ports. So we only got back the 53, the 111, and the 137. We have to remember that we got to specify explicitly the -SS in this one particular scenario, and then the -SU together to make sure that we run both types of scans. And of course, by this example, you can see we can run more than one of those scanning types at the same time, or at least in the same command. And there's our full results. When you're scanning big network ranges, a lot of this stuff becomes more important to be more efficient because any small mistake you make in the configuration, you'll never notice when you're scanning one host or even probably 256 hosts. But when you start to scan the Class Bs, the 16,000 hosts, all those tiny little errors will be multiplied by millions, and the scan times can go from, it can literally vary in difference between a scan that might take you a couple of hours or a couple of days to taking a couple of months based on just how you configure the scan itself. And of course, at a couple of months, the chances of you actually keeping that network connection alive and the host running and everything, not too good. So, okay. There is this -R option. It's disabled by default. You'll notice that the ports are scanned in just a random order. And that's done to help avoid detection. If things are scanned in a perfect order, it'd be kind of obvious that the tool was running, and you probably would even be able to tell which tool was doing it. But for demos, you may want to consider the -R option because it makes the output easier to see in TCP dump. So if you're passing this information on, and we'll add the -R, probably should make a more obvious range. So we'll do, say, 1 through 5. So we got this nice output, 1, 2, 3, 4, 5, with all these sends sent in them. And then we got back the replies. Those replies obviously came back in a somewhat random order. It just depends on how fast the target received and processed those responses, and they sent back the resets. Is there any questions on that section about service scanning and how service scanning works compared to the service probes, or comparing the service probes against just the top ports file? All right, so Nmap has the ability to try to detect the operating system, and in concept, this is similar to the way that it discovers the services. It has probes that it sends out, and then it watches for the replies that come back from the target. Now, typically, the operating system detection is going to require that you find at least one open port and one closed port on the machine. And just because you find an open port doesn't necessarily mean you're going to find a closed port. If you had a dedicated web server, for example, you may find that port 80 and port 443 are open, but every other port may be blocked silently by firewalls that are protecting that web server. So it is important to note that you do need to have an open and a closed typically in order to get a good assessment on the operating system. Like the service probes file, there is a database that contains patterns that match certain operating systems. That's in the same directory as the other files. And we see it over here in Nmap OS DB. If you want to take a look at that, you might use the less command just to keep the information from scrolling off the screen. This fingerprints file gets updated periodically. Whenever you get a new version of Nmap, you can do, I guess it's apt-get and install Nmap. It'll download the new version. So here's the file, and these are types of responses, types of probes, I guess you would say, that it's looking for. So this is is that the congestion window that you were talking about earlier, Adrian?
Yeah, I'm not sure.
And then the window, and these are all defined out on the Nmap website. So you can take a look and see what the probes mean, and then also what the responses mean. But these are effectively they're patterns that if all of these patterns match, then there's a good chance that this operating system matches the specified. So down here is one that apparently matches the PoreTech MV374, for example. Now it is possible that the machine could match multiple ones of these patterns, and so you may get a situation where Nmap says, "Well, I think it's this, but it could also be that," and it'll have kind of a confidence level. Oh, that one's pretty interesting. I didn't even notice there was a doorbell in here, so maybe it'll fingerprint your doorbell. No. Do you have a voice doorbell?
No, I don't.
Okay. Probably not literally a doorbell. It's probably like a service, I guess. So, I don't know. Maybe it is literal. Maybe there's actually a VoIP doorbell. Who knows?
ADP does have a thing, man.
Do they really? Okay. All right. I wasn't taking it literally, but maybe it is literal.
If you want to take things literally, it could be.
It could be. Okay. So, the basic format of that file is that you have those fingerprint blocks that we were looking at, and they start with the operating system's name. We saw the couple different operating systems, and then there's a general class, that category that the block represents, and then the response data that it's trying to match. The response data is effectively the fingerprint data, the match data. So if you want to try this, go ahead and start Nmap on your target. I'm going to use just the Metasploit again, Metasploitable I should say, and do the -O. Now by not specifying any other options, we are doing a default send scan at the same time. So in the background, Nmap is going to make note of one of those ports that's open that we found earlier, and then also one of those 977 ports that was closed that we saw earlier. And it'll use a couple of those to do the fingerprinting. And the fingerprint comes back as a general purpose device running Linux 26X. Now sometimes you're going to have computers that you can't map very well, or maybe the default mapping doesn't bring back the result you expected, or perhaps no results at all. It is possible that it can say, I have no idea what operating system this is. So there is a couple of alternative options that you can combine with the -O, and you do need to combine them. They don't go by themselves. There's the limit, which says, don't waste your time. If you can't figure out what the operating system is right away, just forget it. And then there's the one, the OS guess, which is spend an extra time or be more aggressive about the matches you try to do to try to figure out the operating system. So we'll try those. Do an OS limit first. Let's see, I think I got the syntax wrong. Oh, OS scan limit, sorry. I even said it wrong. Okay. In this case, it basically got the same answer as earlier, the Linux 26X. So in this case, even though we said, don't waste too much time on this process, it was able to figure it out anyway. And then we can do the OS guess. Don't forget that you still have to say -O. These are modifiers, they're not really options in themselves. At least not standalone options. Okay, and we get back the same answer. So one of the things I think is kind of interesting is if you run the Nmap-O on Kali itself. It's a pretty popular operating system. And by any reasonable measure, a lot of people use it all the time.
Something I learned here after just like 10 years ago.
What is it?
We did see like we would hit D or E. It'll give you the current state.
Oh, okay.
It'll give you like an ETA and
Okay.
what hosting you're scanning and stuff.
Let's try that here in a second. He was the comment was about the C option in addition to the D for debug and the V for verbose earlier. So we'll take a look at that. So in this case, there was no match found, no exact OS match found, and notice that Nmap dumped out this fingerprint, and then you can take the fingerprint that it dumps out over to the Nmap website and submit it if you happen to know what operating system that is for sure. Now they'll have a drop-down box that asks you why you think you know what this operating system is, because they don't want a bunch of submissions and have people guessing. They would kind of like to know for sure that that's what it is. But if you've got some kind of weird device on your network, maybe the television or the Blu-ray player or something like that, and so you're scanning your home network when you get home, and I know you all will, right? So there's going to be a bunch of smart TVs that you're going to figure out aren't so smart when they don't turn on anymore. So if you see these fingerprints and you know for a fact that that's, whatever, the Sony Bravia HD Max or whatever, then you can take all that information over to the Nmap website, turn in the fingerprint, and then in a couple of versions you might see your fingerprint show up. I was always curious why they can't identify Kali. Never really had it figured out.
Actually, this one did.
Did it?
Yeah, if you go to 10.0.0.104.
104?
10.0.0.104.
104.
At least mine did. I don't know.
Let me see if I'm on the network.
It may be because it's technically, Ubuntu?
Could be. Mine specifically says Colin.
Well, it says that as the host name. It's probably saying that.
You're right. You are exactly right, sir. Yes.
It's
That's the
probably because
default
it's a
host
flavor
name,
of
you're right.
and that has other options than anything.
Right.
Yeah, back then I used to use BT, so I know someone on campus
Yeah.
because they had
Right.
BT dot university name.
And a lot of people don't change their host name. Right.
Well, or if you're running a live CD or USB.
So disregard my comment.
I can't reach it anyway, so
It's okay.
I won't be able to test it
That
out for
theory
you.
was shot down.
Okay. Yeah, it doesn't identify.
Right. You can name it whatever you want. And
Yes, the host name can be named whatever. So yeah, in fact, somebody could name something Kali and it's really Windows. Just trying to be slick or whatever. Okay, and then let's see. I'm going to scan this entire network. And just hopefully that'll take enough time where we can check out that C option. So we hit C, it dumps out the current status or what's going on. Cool.
It's the same thing as hitting enter, basically another key that's not an actual.
Oh, okay.
So you can hit space, you can hit enter, you can hit it.
Oh, okay, yeah.
Y.
Actually, I'm just hitting random keys right now.
Yeah.
There you go.
So, cool. All right. Yeah, I don't know why. I usually use the space bar. I think it's just a habit I have of hitting space, but that'll also turn down the debugging. So if I turn all the verbosity off, the scanning. And then you just hit the space bar, I guess it does the same thing.
Okay. I guess I just never noticed it because I never hit anything but here.
Oh yeah, V or D or space, yes, or space bar in my case, or enter. A lot of people hit enter, of course, just out of habit, I guess. So this is the link to the submission, but of course, if you just Googled it or went to the Nmap website, you'd see that it's nmap.org/submit if you wanted to submit some more fingerprints. And they have a good explanation of what the fingerprinting symbols mean and how that works, what all those little letters meant and the percentages and so forth on their website as well. The Nmap book, actually I think Martin has a copy of it here. It's on their website, more or less the same information for free. All right, so we did the operating system, and I believe we did the services as well. We'll skip down here to the scroll so much slower when you're in when you've got it zoomed in. Okay, so we'll look at some of the scan accuracy. So these are the options that you can have. But let me just throw this disclaimer out right now. It's pretty hard to get the options correct enough to where you can beat Nmap's default timing. It's pretty fast the way it is, and it does some tests during the assessment of larger networks. It looks at some of the timings that come back, like how long did it take this packet and that packet to get back, what kind of packets are coming back, and that sort of information. And it uses that to change the scan dynamically while it's running. So you may notice that, especially if you're looking at the debug output, that some of the values will change over time, and that's because Nmap is smart enough to know that the network is not responding to this or that. It's going to try something a little bit different. Actually, if the network is doing really well and responding gracefully to different transmissions, it'll speed things up too. So it doesn't always just go slower. It can go faster as well, depending on how the network's doing. So I think Martin mentioned earlier, he basically runs the ping scan on full blast, like T5, and the others, I guess he runs T3.
Depends if you're supposed to be there or not.
Yeah, okay, so maybe T2, perhaps. T1 takes a belligerently long time to finish, so I'm not sure if that would be good unless you were scanning like a Class C or whatever. So we'll take a look at a couple of those. But in general, the parameters that we can influence in Nmap would be how many hosts to scan at one time. Actually, this does seem to help a little bit if you bump this number up and make it a power of 2. Having a nice host group to work on at once is good if the network can handle the traffic and respond back to you and you're not too far away. So these RTTs are round trip times. So how long are you going to wait for packets to return? When do they time out? When's the biggest number they can time out? And what's the initial value? Now remember, Nmap can adjust these within these ranges during the scan. So what you're basically doing is you're putting bounds on the upper and lower limits of those. The max retries is how many times it'll try the same exact probe again. So you could have 3 or 10 or whatever, and that would be the number of times it would try TCP port 21 on host 101, for example. Now you can give up on the hosts themselves after so many minutes. I think the default is 30 minutes if I'm not mistaken. And the host timeout is a little, you don't want to set it too low, because if Nmap had actually gotten, say, 75% of the way through the ports on the host and it reaches the host timeout, it doesn't tell you the 75% of the information that it worked hard to get. It just forgets the entire host, and all the results are discarded for that particular host. So, and then you can also send packets at certain rates. So you can say, I don't want to send any more than so many packets or any less than so many packets, and really dial in how stealthy or how noisy you want to be, how aggressive do you want to try to crank it up. Now, typically what most people do is they'll use the built-in templates, and the templates contain groupings of these options. So here in the T1 speed, the really slow speed, we can see that the values for host groups and is obviously a very broad range, and the timeouts are set very high. It's kind of assuming a relatively slow network, you would still get information back on, and then it starts off the other values in a similar way. When you see a 0, it's not literally a 0. It means that it's unbounded, I guess is the best way to put it. So the T2, try not to scroll up too fast, keeps most of the same values. This is still a very conservative scan, but it's going to start out with the different round trip times. So the timeouts on it, and then there's T3. This is the default. If you don't specify what timing you want, you're running at T3 speed, and that's the speed that you've probably been using for most of the day. It's pretty accurate. It has a nice balance between performance and accuracy. It's probably, in most cases, going to find all the ports on the machine, and it's probably going to run in a fairly reasonable amount of time, especially if you're scanning your own networks, or even if you're scanning your networks at work. You may not necessarily be on the same subnet as all the machines, but you're still in the same, corporate network or company network. It's probably going to do very well. And the T4 works pretty well, but you can expect to start to miss some ports at this point. Once you start to switch over to the 4 and especially the 5, you're going to miss some information, because you're going to be sending out stuff so fast and you're going to be timing it out so fast that the packets are not going to have a chance to make it all the way to the destination, get processed and responded to, come all the way back to your machine in time to process it before the timeouts occur. And then T5 is just crazy. Matter of fact, I think the pseudonym for it is even insane or something like that in the scan. You can use the numbers or you can use the words. All right, let's do some tests back on Metasploitable. Remember, there was 23 open services earlier. So if I do T1, we'll just be here all day because it will never get done. So we'll not let this run very long, but just to show. In fact, let me run it with the verbosity turned on. Okay. So it's going to do the ping scan. It's doing the ARP scan actually, because it knows that that host is on the same network as us. But if you all are doing this same lab over here, you're on a different subnet. When you join the student network, trying to hit the backbone network, you're on a different subnet, so it's probably not going to do ARP. It would do just a regular ICMP. And then it's initiating the send stealth scan, and it's going to be super stealthy because we're sending so few packets, and we're sending them with so much space in between them that we're probably not going to trip any intrusion prevention or intrusion detection systems. Even though those types of systems are stateful, like stateful firewalls, they don't remember things forever because they have to continue to process the next traffic and the next traffic that keeps coming on behind that. So they do time out their memory and forget about things eventually if you give them enough time. Well, we found 2 ports.
We can still get caught by log correlation though, right?
Well, that would be like a SIM tool, you mean?
Yeah.
Yeah. Well, if you, that would be different than an IDS IPS. But if you had a SIM in addition, the security incident event management or whatever that stands for tool, then yeah, it could do correlation because it doesn't forget, so it logs everything. But that would be typically most times that's an add-on from your provider, usually expensive. All right. Well, we're 0.35% done, so. Either come back tomorrow or we can just cancel this. Control C. Most, generally on the Linux command line, most of the time Control C will stop whatever program, but some programs, when you kill them right in the middle of their job and they don't die gracefully, so it just depends on which one you're working with. But in Nmap's case, it'll work. So if we bump it up to the T2, now one of the things you can do as well, if you wanted to see, let me clear this out and do that again. So try to stop it pretty quickly. Okay. If you wanted to see what the timing was, if you give it the debug, the -D option, then you can get the timing report spit out at the beginning, and it'll tell you what those timing values were for that particular template that you applied. So this is the T2 template timing report. And that's one of those cases where you would have to pass that in as the command line switch. You wouldn't be able to hit the D key fast enough, probably, to get that report to spit out, because it comes out right at the beginning. And I'm not sure exactly how many of the letters that you have to have. I guess we could test that. Looks like 1 is playing, so the -D option will print out that report. So obviously the 2 is going to go a little bit faster, but it's still pretty slow. If you have to be stealthy, this probably is the best template to pick. I guess it would depend on the brand of the scanner, the detector that's trying to detect you, and it would also depend on how they have it configured, because all of those detectors have lots of configuration options, and so just because they're using a particular brand of IDS or whatever doesn't necessarily mean they would or wouldn't detect you. You would have to do a test. And that's where it would come in handy to maybe try some of those, if you could get some of those bounce scans or those idle scans that Adrian was talking about earlier, to poke at the network and see.
That's one of the nice things about the bounce scan also is you can find a printer external, but also it's firewalled off. You can possibly bounce something off the printer and see what's up, an open port on the inside.
Yeah, maybe get, yeah, if you could find something like that on the external network, that would be great for a lot of reasons, because you could access the internal network. Okay. All right, still pretty slow, but at least it got to 14% before we killed it off. We'll switch to T3. We've seen this one before, so I'll just go ahead and kill this one. We've been doing that one all day long. Okay. Now we'll go to T4, and we'll go ahead and let this one finish, and then you can kind of compare the amount of time it takes for this T4 against what we've been used to in the other demos. All right, so, oops, there's the results. Okay, and we still got 977 closed. We were doing the top 1,000 because it was default settings, so we still got 23 ports. T4 is a winner. Let's try T5. That was fast. All right, and it still found all the ports. I found that sometimes even when I was testing on the host-only network, the T5 was so aggressive that occasionally it would miss a port, even though it's not only the same subnet, it's literally the same host. It's the same computer. It's just a virtual network, which a virtual network should be almost infallible, but just because the latency would be so low. But occasionally it did actually miss something. So that's kind of a fun one to experiment with, is do a T3 and a T5 and compare them to one another, especially if you're going to cross through a router on your way to the target. In other words, if the target's on a different network than you. All right, was there any questions on the timing of the scans, or how to set the timings up, what the effect might be? I've done some T4s against large blocks of machines on the internet, and it worked pretty well. Mainly what I used it for was to find the machines. When you're doing scans, on a large network, or you're doing them for a company and you would rather send as few packets as possible, you're generally going to break the scans up anyway. You're going to do a host discovery scan first and take the hosts that you found and put them into a file, and then feed that into subsequent scans to do the port, to detect the ports. You don't really want to have, at least in large networks, have Nmap running the defaults on large ranges, because it's going to check, every single host in turn looking for all the top 1,000 ports, and it can slow things down. If you break the scans up into small chunks, you can avoid sending a whole lot of unnecessary packets. Do your host discovery first, populate a file with those IP addresses, feed that back into a port discovery, figure out which ports you want to do the service version detection on, feed that back into a service discovery scan, a third scan, and then proceed to the Nmap scripting finally with the services that you find interesting. That way you're not doing a service version scan on every single port found on every single host in the network. Okay. And the last module for part 2 today is looking at how to fine-tune some of the output. So Adrian had covered the output options earlier. There was the OA for everything, the G for grep, the default, and then there's also the XML. The XML format can be imported into a lot of different devices or management systems, things like Metasploit, Nessus, Qualys, and other tools that can use the XML to know what the targets are for that tool to carry on with. I believe Nexpose scanner also will import natively. All right, so let's take a look at some of the output. First of all, we'll go ahead and make some output. So we're going to use the -OA option. And in this case, we only have to give it a base name. We don't have to give it the extension. So this is our test scan. We'll just try that real quick. Then we'll do an ls to see what files are output. And then we'll try to look at the XML file and see if we can get it to be formatted. So let's see, let's move this up. If we do an ls, we can see that there's a testscan.g, Nmap, and XML. And then you can try to look at the XML in the Firefox to have a nice report. But you're going to have some problems if you try to do it right away. Okay, so, oh, in this case it worked. I think I've already copied the files over if we needed. Probably should have deleted those. So it actually worked, and it produces a nice report. As you can see, it's all formatted and styled and everything. If you have multiple hosts, it repeats these sections for each host. So you can go ahead and give that a try on your machine. Oops. Okay. But if we look at the XML format a little closer, so one of the things you'll notice here at the top is the style sheet that it refers to do all that formatting. So if I were to change this, sometimes you'll end up with some problems. Like, for example, if you weren't on that machine or anymore, like you had, say you had emailed the XML file off of Kali to your manager who's running Windows, right? And so you're like, hey, check this out, just open it with Internet Explorer. Well, they open it as a big blank screen, right? And the Price is Right wah-wah sound plays in the background. Well, what you got to do is you have to remember that you have to point to that XSL file that's going to format that in the browser. And you need to send the XSL file along with the XML file. But even if you did that, it's not going to help because the default for this file is the Kali address, user bin, sharing map, all that kind of stuff, right? So one of the things that you can do when you run the scan in the first place is specify, relatively speaking, where do you want to refer to that XSL file, and what's the name of it? What's the name of the file going to be? And you can do that with the style sheet. And we can just say nmap.xsl. That's the default name that the nmap.xsl would be anyway. And you'll notice what that one little switch will do is it'll change that file href in the XML document. Okay, so now it's just nmap.xsl, what we said earlier. So if you were to send the XSL and the XML together, then when somebody opened up the XML in their browser, the XSL would be right there next to it, and it would all work like magic. Now, if you need to fix one of the XMLs because you already have it printed out and it took an hour just to get the XML to print out and to be created in the first place, don't bother running the scan again. Obviously, just open up the XML in some kind of tool. So if we did like Nano, for example, I probably just made like 50,000 V followers. So angry they turned video off. But anyway, you can come in here and just modify that href to point at wherever that XSL is. For simplicity, I usually just keep it in the same directory. That way I don't really have to think about it.
Coming in, quick announcement. Everybody, for just a bit, can you disconnect from the backbone network if you happen to be using the backbone network? Thank you. I'm fighting for an IP address.
Oh, that might have been me.
What are you doing?
I was just trying to borrow it because the student network wasn't working, and it said, and I was just using DHCP, so it said the IP address was already in use.
I don't think you're the only person doing that, though. Everybody disconnect from that one for the time being.
Everybody's trying hard.
Scan each other if you want to on 192.168 something something. Yeah, I hope you're all going to give me one. Actually, it's one something there.
To copy to locate the nmap.xsl on your machine, you can use the locate and then just type in the file name. Not just for this file, but any file pretty much in Linux. If that doesn't work, you can always update the database that stores the locations and stuff with, I think it's a DB update or something like that. So there's a couple of files. There's one in my home directory here that I've copied off like 1,000 times, plus all these other ones I've been copying for, it seems like, forever. So one of the easiest ways to copy it over, if you don't really know where it is just do a copy and then run the locate command on the command inline with the little $ symbol. So if you say nmap.xsl, whoops, crap it out, XSL, and put it here, dot means here, then you can just say, oh, well, it'll go out and try to find a copy of it and put it there. But the problem is anything that also matches that pattern, like dy nmap.xsl, will also get copied over, so then you have to turn around and remove those. Okay. So now we have our nice report. And I'm going to remove these test scans out of this directory because they don't belong over here. I thought it was in my home directory. I'm actually over in the Nmap directory. So not a good idea to pollute that one. All right, any questions on the output and getting the report formatted correctly and getting it to show in the browser? Those reports are super handy too because you can print them out and then just use them almost as like a scratch pad while you're doing your test. You can sort of cross off services as you test them and move on down the chain. Okay, so there are some other options that will modify the logging, and one of the nice ones is the resume that Adrian had talked about earlier, where as long as you were logging the output to the graphical format or whatever, then you can resume from where you left off earlier. Maybe the battery died in the scanner, laptop, or whatever reason. So you can also refer out to the style sheet that's on nmap.org with using the web XML. Typically don't do that because you have to have internet connectivity for that to work, and whoever that you're trying to give the report to may not necessarily have that. It's safer, it seems, just to send the XSL along. So. All right. You can also customize the XSL if you want to change the format of the report. Just go into the XSL and add or delete as you see fit to get what you want. So if I go back over to the home directory, I think I have a copy of one that I modified. Let's see. Yep, there's the Nmap host port summary. So let's get some output going. We'll do -OX for XML, and we'll do test scan.xml. I need to add the extension because I'm not using -OA, I'm using -OX. equals, and I'm not going to try to type that. Copy and paste that over, and it was 192.168.56.101.
If you already have the file there that you're trying to specify as the output, will it overwrite it? Will it append to it? Will it not write out at all since it already exists?
Oh, it overwrites.
There is an end.
Yeah, output append option, I think, the dash dash output dash append, and that'll add to it. But you have to specify that flag.
Okay.
Oh, there it is, testscan.xml, so Firefox testscan.xml, excuse me. I probably should make sure that but basically you can see this is a stripped down version of the standard one that we made because we just wanted to dump these tables real quick. When we're scanning, a very large network, it got really hard to read these output files because there were so many hosts, and the sections were broken up by those blocks of detailed explanations about certain ports and certain protocols. So we created this XSL just to dump a real simple listing out that we can print and work off of as kind of a checklist without killing 5 million trees and having to flip through pages to see things. So hopefully that makes sense. And of course, how you modify that is up to you. You just have to kind of figure out what the format is a little bit, and then remove a section or two at a time that you don't want to see, and then try it. You can always go into an existing scan result and change where it's pointing to. You don't have to run a new scan. And if you have a scan you've already run that has 1,000 hosts you found in it, you obviously wouldn't want to keep running that scan over and over again just to test the format. Alright, I think we pretty much covered how to fix the XSL if they're broken or if they're not pointing to the right place. And earlier when we were talking about the services file, you can do the same thing. If there's a whole lot of services that you're just not interested at all in doing the version scanning on, you can go into the versions file and delete all the ones out that you're just not looking for right now. And that'll greatly speed up the scans, especially the service version scans, which tend to take a very long time. And I have an example here.
All right, if anybody's still connected to the backbone network, please disconnect. I'm trying to make it to where it frees up more IP addresses via DHCP. For some reason, I can't successfully, even over Ethernet, get connected. So if you're connected to Nmap backbone, Nmap class backbone, please disconnect. And don't scan it. Don't Nmap anything but 192.168 numbers.
This is a probe file I made a few weeks ago. It only looks for the MySQLs and nothing else. And so I just took the 2 probes that MySQL responds to, plus all the matches for those respective probes, being careful to keep them in the right order, and copy those over to a file that does nothing but look for those particular probes. And of course, that'll speed things up a lot if you're just interested in looking for that particular service and figuring out what it is.
So then are you able to specify that particular file during your scan?
Yes, so if you, the datadir command, so if you do nmap datadir, and so if I said it was the current directory, for example, and then I did 192.168.56.101, oh, I forgot the -sp too. And it'll tell you which files it's using from where. In this case, it's matching on the name of the file, so you have to be careful that you name your custom file the same name as it was over in the user share nmap directory.
So you can't just create a different one that's named something different and then specify that particular file to read.
Yeah, I don't know. I've never tried to do it that way. I just create one-offs, and I keep them in a certain directory where all my one-offs are, and then I say datadir is equal to that custom directory, And if you didn't want to mess with the probes file, for example, just don't put it in your custom directory. It knows that if I can't find what I'm looking for in the custom directory, to go use the default. So it won't break the scanner or anything like that. And that way, if you update your tool, like you get Nmap version 6.5 or whatever, and those defaults get overridden, you're still using the latest and greatest. Since it works for me this way, I never actually tried to see if I could give it like alternate file names or anything like that. I don't really write the probes. That looks to be really hard to do. I just take the file they have and remove the ones that I don't want, or copy the ones over. In this case, I copied the ones I did want because it was just one protocol. So, all right. So it had a whole lot of trouble with those services because the probes file. So didn't have those services in. So see, it read from local Nmap service probes file. But then, because I didn't have an equivalent, it read from the default of the payloads and services file. All right, your question? So make sure we covered everything. Yes, I think so. So any other questions on formatting or output? Customizing the scanner a little bit? Like that? All right, great. Thanks. Now we've got the really tricky part coming up, the scripts, and also the other evasion techniques that you might want to use. Martin's going to be covering that for us. So you think like 5 minutes, 10 minutes?
I don't care, whatever.
Okay. 5 minutes. 5 minutes? All right. So we'll just we'll start back up at 10 minutes till 2. So that's about, I don't know, 8 or 10.